Welcome, dear listener, to a story hidden beneath your very feet. Scientists once discovered a series of nuclear reactors in Africa, 2 billion years old, quietly running long before humans walked the Earth. Natural reactors made possible by ancient uranium chemistry and groundwater moderation. Extraordinary reminders that deep time can produce signatures that feel engineered. The problem is simple, and yet it changes everything. If the Earth itself can erase entire landscapes, bury oceans under stone, and recycle even mountains into dust, how could we ever know if civilizations rose and fell long before ours? Imagine, just for a moment, that you are not the first. Imagine that other eyes once looked at the same stars, that other hands once shaped this planet, and that their entire world has been swallowed by time, leaving behind only whispers in stone. So I ask you, what if our history is not the beginning, but only the latest chapter in a book billions of years long? Because here is the mind-bending truth. If all of human civilization, our cities, our satellites, our digital age, were pressed into the rock record, in just 10 million years, almost every trace would vanish. Skyscrapers, roads, entire nations, gone, as if they had never been. But first, tell me, where are you joining in from tonight? Are you tucked into bed beneath the warm comfort of a blanket, curled safely indoors with the quiet hum of evening around you? Or perhaps outside beneath an endless sky scattered with stars? Wherever you are, let yourself settle. Feel the air around you, notice the stillness, and know that in this moment, you are part of a shared journey across deep time. We will slowly and gently discover how Earth forgets, what would last, and where we'd look, before finishing with a quiet reflection. Most anomalies in rock, ice, and chemistry have natural explanations: volcanism, impacts, ocean circulation, weathering. Our question tonight isn't, did a civilization exist, but how would one show up if it did? We'll prefer ordinary explanations first. If something still resists, we'll ask the kinder question: what else could paint this layer? Tonight, we will drift through that possibility together, slowly, like continents moving, quietly, like fossils turning to stone. And in doing so, perhaps we'll feel both the fragility and the wonder of being alive in this fleeting, extraordinary moment. It is a natural, almost meditative human wonder to gaze out at this quiet Earth, to feel the weight of its age, and to ask a question that is both thrilling and deeply humbling. Has anyone else done this before us? Could this planet, in the deep and distant echoes of its past, have cradled another kind of intelligence, another civilization that rose, flourished, and vanished into the mist of ages long before the first mammals ever scurried beneath the feet of dinosaurs in a world we would scarcely recognize? This is not a question born of mere fantasy, but of a serene and scientific curiosity, a peaceful pondering of the limits of our knowledge and the nature of evidence itself. It invites us to explore the immense, almost incomprehensible scales of geological time, to understand the Earth not as a static stage, but as a dynamic, living entity that constantly erases and rewrites its own surface, and to consider the subtle, fragile fingerprints that all things, no matter how grand or advanced, ultimately leave upon the world. As we embark on this tranquil journey together, we will not be seeking definitive answers, for there may not be any to find. Instead, we will wander through the possibilities guided by the soft, steady light of scientific principles, geology, chemistry, paleontology, and a sense of gentle wonder at the profound and silent antiquity of our home. The concept we are exploring is sometimes known as the Silurian hypothesis, a name borrowed from an old science fiction tale of intelligent reptilian beings, but which today serves as a thoughtful, sober framework for a scientific meditation. It is not a claim that such a civilization existed, but rather a methodical investigation into how we would know if one had. It asks us to consider what truly remains of a world after millions of years have passed. What echoes of our own cities, our industries, and our complex existence would persist after such an unimaginable expanse of time, and would they be discernible from the natural background noise of a restless planet? To seriously ponder a civilization that might have existed not thousands, but hundreds of millions of years ago, is to first understand that the Earth itself is the great recycler, a patient and relentless artist that constantly sculpts and resculpts its surface with forces of unimaginable power and slowness. Mountain ranges the size of continents rise in fiery upheavals, only to be gradually worn down to grains of sand by the gentle, persistent caress of wind and water. Oceans open and close their vast basins over epochs. The very continents drift across the globe in a slow, graceful dance measured in eons, their movement no faster than the growth of a fingernail. In such a dynamic and consuming world, what could possibly survive to tell a tale? The evidence could not be, a buried city of skyscrapers and subways intact, for such structures would be utterly vanquished, ground into dust, and scattered to the winds by the planetary forces of erosion and plate tectonics. Instead, we must adjust our search image. We must look for more subtle, more resilient clues. Chemical whispers trapped in ancient sedimentary rocks, strange and anomalous spikes in the fossil record, isotopic signatures in layers of strata that hint at processes that should not have occurred naturally. It is a search for a ghost in the geological machine, a faint and elusive signal that might indicate a presence, an activity, an agent of change that was not merely geological or biological, but perhaps intentional. It is the ultimate cold case, where the crime scene is the entire planet and the passage of time has erased almost all of the evidence. As we prepare to delve deeper into this concept, let your mind settle into the vastness of deep time. Picture the countless generations of life that have come and gone, each leaving its faint mark, each contributing a single thread to the great, sprawling tapestry of Earth's biography. The possibility we're exploring is that of a single, perhaps missing thread in that immense tapestry. It is a contemplation that requires us to be both imaginative and rigorously skeptical, to open our minds to extraordinary ideas while simultaneously grounding ourselves in the ordinary, relentless, and beautiful processes of geology and chemistry that shape our world. So let us begin this exploration not with a shout of discovery, but with a whisper of inquiry, a calm and thoughtful consideration of the past, and a gentle curiosity about the silent, sleeping epochs that preceded our own brief moment in the sun. Let the immense scale of time wash over you, not as something frightening, but as a deep and comforting blanket, reminding us that our story is just one chapter in a much, much longer book. To truly wrap our minds around the possibility of a lost chapter in Earth's story, we must first find a comfortable place within the concept of deep time, a timescale so grand it can feel less like a measurement and more like a form of meditation. We mark our own lives by years and decades, and our history by centuries and millennia. But the Earth operates on a different clock entirely, one where 1,000,000 years is a common unit, a mere tick of the second hand in the planetary day. If we were to compress the entire 4.5 billion-year history of our planet into a single 24-hour day, the first simple, single-celled life would appear in the pre-dawn hours, around 4 a.m. The great dinosaurs would rule the Earth for a long and dramatic afternoon, emerging just before 11 p.m. and vanishing about 40 minutes later. Our entire human civilization, from the very first agricultural settlements to the sprawling cities of today, would occupy the very last sliver of time, a mere fraction of a second before the clock strikes midnight. This perspective is not meant to diminish our existence, but to expand our sense of wonder, to allow us to see the immense, silent stretches of time that are available for other stories to have been told, other players to have taken the stage. Within this vastness, the reign of the dinosaurs lasted for over 180 million years, a duration so long it is almost impossible to internalize. It is a span of time 40 times longer than the entire current age of our own human genus, Homo. In such an ocean of years, could an intelligent species have evolved not from a primate ancestor, but from a different branch of the tree of life entirely? Could a being with dexterous claws or tentacles, with complex communication and problem-solving skills, have emerged in a world of giant ferns and unfamiliar stars? The fossil record, our primary window into these lost worlds, is both a treasure and a trickster. It is incredibly, profoundly incomplete. Fossilization is a miraculous lottery, a series of specific and unlikely events that must align perfectly for a creature's remains to be preserved for millions of years. An organism must die in the right place, be buried quickly by sediment, avoid being scavenged or decomposed, and then endure the immense heat and pressure of being buried deep within the earth, all before being eventually uplifted and exposed by erosion, just in time for a paleontologist to find it. This process heavily favors hard-bodied creatures that live in or near water. The bones of dinosaurs, the shells of ammonites, the teeth of sharks, these are the common treasures we find. But the soft tissues, the delicate structures, the fleeting impressions of behavior and culture, these almost always vanish without a trace. We have fossils of dinosaurs with feathers, a stunning detail that brings them to life, but we have no fossil of a dinosaur's nest woven with intricate patterns, no preserved tool made of wood or bone, no artifact that speaks of anything beyond instinctual behavior. This is the great silence we must confront. If a non-industrial civilization, perhaps one that lived in harmony with its world without drastically reshaping it, had existed tens of millions of years ago, what would remain? Structures made of wood, cloth, or even most stones would have long since weathered away to nothing. Their art, their writing on perishable materials, their tools, all would have returned to the soil, their atoms recycled into new forms of life. Their existence would be a ghost in the machine, leaving no obvious trace for us to easily uncover. This leads us to a more profound question. What are the most durable signatures of a technological civilization? We must think beyond skyscrapers and statues and consider the subtler, more chemical imprints we are currently leaving on the planet. Our own industrial age, which has lasted little more than 2 centuries, is already leaving a stark and unambiguous mark in the geological record. Future geologists digging into the layers of rock that are forming right now would find a sudden, dramatic spike in artificial radionuclides from atomic bomb tests, a layer of plastic particles permeating sediments across the globe, a distinct change in the ratios of carbon and nitrogen isotopes from burning fossil fuels, and a peculiar abundance of refined metals and exotic compounds never before seen in nature. This layer, which some scientists have proposed calling the Anthropocene, would be a brilliant, glaring signal of our presence that could persist for millions of years. But if a civilization existed before us, it might not have taken the same industrial path. Its lasting signature would be different, fainter, and infinitely harder to detect. The search, therefore, becomes a search for anomalies. It is a careful sifting of the geological record, looking for moments where the chemistry of the air or sea changed in ways that are difficult to explain by known natural processes. It is a search for patterns in the fossil record that suggests something more than natural selection was at work. It is, in its own way, a deeply scientific form of stargazing. But instead of looking out into space, we are looking down into the layers of rock beneath our feet, searching for a whisper from a world that time has almost completely erased. It is a peaceful, patient search, one that requires us to quiet our assumptions and listen carefully to the very old, very slow story the Earth is telling. If we are to search for ghosts, we must know what traces they leave behind. Not the grand monuments, but the faint, enduring chemical echoes of their existence. Our own civilization, in its relatively brief and explosive period of industry, is currently inscribing its presence into the very strata of the planet in ways that will be readable for epochs to come. This provides us with a blueprint, a set of clues for what we might look for from a potential predecessor. The most durable and unambiguous signals are not physical objects, but alterations to the chemical and isotopic compositions of ancient sedimentary rocks, the slow, patient pages of Earth's diary. These rocks form from the mud and silt that settle at the bottoms of oceans and lakes, gradually capturing a snapshot of the atmosphere and water at the time they were laid down. Within them, they trap elements and molecules that can tell a story of sudden, unnatural change. Consider the element platinum, or the rare earth elements. In their natural state, they are found in specific ratios and concentrations, scattered thinly across the globe. But industrial civilizations, with their insatiable appetite for resources, tend to concentrate these metals in high concentrations. This results in a characteristic signature that could be readily detected in the geological record millions of years hence. If anything similar to our industrial age had existed millions of years before us, we might find its evidence not in the ruins of monuments or cities, but in the chemistry of ancient sedimentary rocks. These rocks form from the mud and silt that settle at the bottoms of oceans and lakes, gradually capturing a snapshot of the atmosphere and water at the time they were laid down. Within them, they trap elements and molecules that can tell a story of sudden, unnatural change. Consider the element platinum, or the rare earth elements. In their natural state, they are found in specific ratios and concentrations, scattered thinly across the globe. But an industrial civilization would seek out these elements, concentrate them, use them in various technologies, and ultimately, through waste and disposal, create localized deposits of shocking purity and abundance that would appear completely anomalous to a future geologist. These deposits would not look like natural ore veins formed by hydrothermal flows over millions of years. They would be sharp, concentrated, and geologically bizarre, a clear signature of extraction and refinement. Similarly, the widespread use of fertilizers in agriculture would leave a massive nitrogen isotope spike in sedimentary layers, a signal of a global alteration of the planet's nutrient cycles. Our burning of fossil fuels is creating a distinct carbon isotope anomaly, a fingerprint of taking vast amounts of buried carbon and pumping it rapidly into the atmosphere and oceans. This, too, would be recorded in the shells of microorganisms that formed their skeletons during that time, preserving the unusual chemical signature in limestone deposits for millions of years. Perhaps the most long-lasting signal of all would be from nuclear activity, The detonation of atomic weapons, or even just the large-scale processing and use of radioactive materials for energy, creates unique radioactive isotopes that do not occur naturally in any significant quantity. Elements like plutonium-244 or specific ratios of neptunium isotopes would be a dead giveaway, a techno-signature that screams of a civilization that mastered the atom. These artificial radioactive nucleotides would settle into sediments worldwide, creating a thin, global layer that would remain detectable for over 100 million years due to the long half-lives of some of these elements. It is a sobering thought that our most enduring mark on the planet may be this faint radioactive whisper. So, in our search for a prior civilization, these are the clues we would seek. We would carefully analyze geological strata from periods of apparent stability, looking for these sudden, inexplicable chemical spikes. We would search for layers where the normal, gentle fluctuations of Earth's systems are interrupted by a sharp, geologically instantaneous event that points to a massive, directed redistribution of the planet's elements. It would be a needle in a haystack of unimaginable size, requiring not just luck, but a deliberate and thoughtful scientific investigation. The absence of such a signal, of course, is not proof that no civilization existed. It might simply mean they chose a different path, one that did not involve intensive mining and industry. They might have lived in a truly sustainable balance, their technologies and energy sources leaving no lasting chemical scar on the planet. In that case, their passing would have been as gentle as the fall of a leaf, leaving behind no more trace than a whisper on the wind. A possibility that is in itself a peaceful and humbling thought. Their story, if it existed, would be the most quiet and subtle of all, written in a language we are only just beginning to learn how to read, the language of deep time itself. As we continue our quiet contemplation of Earth's deep past, we must now turn our attention to the most tangible evidence we have of ancient life, the fossil record. This vast museum of stone and mineral holds the remains of countless organisms, from the smallest trilobite to the most immense sauropod. Yet, for all its richness, it is a collection of profound and echoing silences. Fossilization is an exceptionally rare event, a fragile miracle that requires a precise convergence of conditions and is fiercely biased towards preserving the hard parts of creatures that lived in environments conducive to rapid burial. This means the record is overwhelmingly filled with shells, bones, and teeth, while the evidence of soft tissues, behaviors, and intelligence, especially of a kind that might not have relied on hard physical structures, is almost entirely lost to time. When we ask if an intelligent species could have evolved millions of years ago, we are not asking if we would find a fossilized city. We are asking if we might find the fossilized equivalent of a whisper, a subtle hint of behavior that transcends the purely instinctual. What would such evidence look like? In our own history, the earliest solid evidence for complex human behavior comes not from our skeletons themselves, which are nearly identical to our non-cultural ancestors for a long time, but from the artifacts associated with them. The progression from crudely chipped stone tools to finely crafted spear points, the evidence of controlled use of fire, the deliberate burial of the dead with grave goods. These are the markers that archaeologists use to trace the dawn of our culture and cognition. These artifacts are themselves incredibly rare and fragile. Now imagine the impossibility of such evidence surviving not for tens of thousands of years, but for tens of millions. A stone tool left on the surface would be shattered by freezing and thawing, ground down to sand by wind and rain, and swallowed by the shifting continents within a few million years. A buried settlement would be subducted, metamorphosed, and eroded away. The fossil record for any terrestrial animal, let alone a rare and intelligent one, is vanishingly thin. For example, the entire fossil record of chimpanzee ancestors is barely a handful of teeth and jaw fragments. Yet we know they are intelligent social beings. A species that did not leave behind abundant, durable bones would be virtually invisible to us. So we must think of other, more indirect evidence. Perhaps we might look for anomalies in the fossil record of other species. If a hypothetical civilization practiced large-scale agriculture, could we find evidence of it? Might there be a sudden, unexplained dominance of a particular plant species in the pollen record, a monoculture that seems out of place with the surrounding ecosystem? If they altered landscapes, could we find strange patterns of soil erosion or sedimentation in ancient layers that suggest terraforming rather than natural geology? If they engaged in hunting or husbandry, could we find bone assemblages that show selective patterns, a specific age or species profile that cannot be explained by a predator's habits? Another avenue to consider is the possibility of medical or biological engineering. If a species had advanced knowledge, might they have left a trace in the genetic record of other organisms? While DNA itself degrades over such immense timescales, the evolutionary pressure exerted by a dominant species can leave a lasting imprint. The sudden extinction of a prey species or the rapid evolution of another to fill a new niche could, in theory, be a signature. But these are all shadows upon shadows. The evidence would be circumstantial at best, a pattern so faint it could easily be dismissed as an oddity, a quirk of natural selection we do not yet fully understand. The great, deep silence of the fossil record is the biggest hurdle to this idea. It is not evidence of absence, rather the absence of evidence, a crucial distinction. The Earth is an active, living planet that constantly renews its surface. The rocks that contain the fossils from 100 million years ago represent only a tiny, tiny fraction of the world that existed at that time. The vast majority of that history has been pulverized, recycled, and lost forever. Therefore, the search is not for a smoking gun, but for a faint, curious scent of smoke on a wind that blew long before our species ever walked the Earth. It is a search that requires immense imagination, tempered by rigorous scientific skepticism, a willingness to ask, what if, while fully accepting that the most likely answer is that we are alone in time, the first and only of our kind. Yet the act of asking the question opens our minds to the sheer grandeur of deep time and the humbling possibility that our own mark on this planet, however loud it seems to us now, may one day be nothing more than a thin layer of strange chemicals in a rock, a mystery for some far future being to ponder. To fully immerse ourselves in the question of a prior earthly civilization, it is peaceful to lift our gaze from the terrestrial layers of rock and soil and to look outward toward the silent, watchful planets of our solar system. They hold a secret to this mystery, one written not in fossils or isotopes, but in the relentless and unchanging nature of celestial time. While the Earth is a dynamic, living world that constantly erases its own past, other bodies in our cosmic neighborhood are frozen in time, their surfaces acting as ancient archives, preserving records of impacts and events for billions of years with a clarity that our active planet cannot match. The Moon, our constant companion, is a perfect example. As far as current high-resolution surveys show, the Moon holds no obvious, non-human artifacts, pointing away from a spacefaring precursor in the last few 100 million years. Its surface is a museum of cratering, a testament to the violent bombardment that characterized the early solar system. Because the moon has no atmosphere, no water, and no plate tectonics, a crater formed 4 billion years ago remains almost as pristine today as it was when the impact occurred. This gives us a stable timeline against which we can compare Earth's own turbulent history. If a civilization on Earth had achieved spaceflight capabilities, even of a rudimentary nature, it would have almost certainly left artifacts on the surface of the moon. A lunar lander, a rover, or even just the discarded debris of a mission would sit upon that gray surface, untouched by wind or rain, for hundreds of millions of years. The slow rain of micrometeorites would sandblast it over eons, and the extreme temperature swings would fatigue the metals, but the fundamental structure and composition would remain as a stark artificial anomaly against the natural regolith. Our own Apollo landing sites, with their descent stages, lunar rovers, and even the footprints of astronauts, are expected to remain recognizable for at least another 10 to 100 million years. Therefore, the absence of such obvious technological debris on the moon, which we have mapped in great detail, is a quiet but powerful piece of evidence. It suggests that no industrial civilization capable of spaceflight has arisen on Earth in the last several hundred million years. This is a profound and calming thought. It narrows the window of possibility immensely, suggesting that if a civilization did exist, it was likely pre-industrial, perhaps even pre-agricultural, living in a way that left no mark beyond its own world. This astronomical perspective extends beyond the moon. Other planets and moons also act as silent sentinels. If a civilization had reached a level of technology that allowed for interplanetary travel, even just within the solar system, we might expect to find evidence of their exploration or resource gathering on other geologically stable bodies. Mars, with its ancient preserved surface, would be a prime candidate for such search. The asteroids, some of which are essentially untouched planetesimals from the dawn of the solar system, would hold evidence of mining activity that would be glaringly obvious against their natural, undifferentiated composition. Our own probes and telescopes have seen no such evidence. The surfaces of these worlds tell a story of natural, undisturbed processes stretching back billions of years. This does not completely rule out the possibility of an intelligent species existing long ago, but it does effectively rule out a technologically advanced spacefaring one. It gently guides our imagination away from visions of ancient starships and lunar bases and back toward a more subtle, earthbound possibility. It suggests that if a civilization did flower in some distant epoch, it was a child of its world alone, its thoughts and dreams perhaps never reaching beyond the atmosphere that nurtured it. Its rise and fall would have been a uniquely terrestrial event, its story written entirely in the language of biology and geology, a language that the Earth, in its constant state of renewal, is very good at forgetting. This realization is not a disappointment, but rather a focusing of our inquiry. It makes the search more intimate, more subtle. We are no longer looking for the grand artifacts of an empire, but for the faint, biological whisper of a clever, conscious being that lived and died as part of the natural world, leaving behind perhaps nothing more than a curious pattern in the fossilized mud. A pattern that we must now, with great patience and humility, learn how to see. As we gently narrow our search from the grand cosmic scale to the subtle earthly one, we must prepare our minds for a possibility that is both fascinating and deeply humbling. If a non-industrial intelligent species did evolve on Earth millions of years ago, its intelligence and its technology might have been so fundamentally different from our own that we would struggle to recognize it, even if we were looking directly at the evidence. We are, after all, prisoners of our own cognitive and cultural biases. We tend to imagine intelligence as a linear progression towards something resembling ourselves, toward tool use, language, and the mastery of our environment through engineering. But what if another path were possible? What if a species developed a profound and sophisticated culture that was more deeply integrated with its ecosystem, one that left a minimal physical footprint? Their technology might not have been based on metallurgy and combustion, but on biology and chemistry. Imagine a civilization that mastered the art of guided evolution, gently shaping the plants and animals around them to serve their needs without the need for factories or mines. Their greatest achievements might have been magnificent living architectures, cities grown from genetically guided trees, transportation systems using cultivated giant organisms, and communication networks utilizing subtle biochemical signals or even bioluminescence. After 50 million years, what would remain of such a world? The genetically modified species would have either gone extinct or reverted to a wild state through natural selection, their engineered traits fading back into the background noise of evolution. The great living structures would have decayed and returned to the soil, leaving no more trace than a natural forest. Their entire technological base would have been biodegradable, designed to fade away without a trace. How would we, with our focus on stone, metal, and plastic, even begin to recognize this as a technological signature? We might dismiss the unusual concentration of a particular fossilized plant species as a curious paleoecological anomaly, never guessing it was once a cultivated crop. We might find a strange fossilized structure that looks like a giant, twisted hive and classify it as a bizarre, unknown geological formation or an immense coral reef, when in fact it was the remains of a living city. Furthermore, their very mode of consciousness might have been alien to us. Human intelligence is intensely focused on manipulating our external environment, but another species might have developed an intelligence turned inward, focused on complex social structures, deep memory, artistic expression, or spiritual understanding of the world. Their greatest legacy might not be in altered landscapes, but in the songs they sang, the stories they told, and the knowledge they passed down through generations, all of which would vanish the moment the last of them died. There would be no stone tablets, no durable artifacts to mark their passage. Their technology might have been neurological, a way of using their own minds to achieve states of awareness or communication that we cannot even conceive of. The evidence for such a civilization would be perhaps the most fleeting of all, a statistical anomaly in the fossil record. A sudden, brief burst of seemingly inexplicable complexity in a certain lineage, a period where the patterns of extinction and speciation don't quite follow the expected models. A fossil that shows a level of care or organization that seems to go beyond the instinctual, like a buried group arranged in a pattern that suggests ritual. But these are the faintest of whispers, easily explained away by gaps in our understanding or the simple strangeness of the deep past. To even entertain this idea is to practice a form of intellectual humility. It asks us to let go of our human-centric view of progress and to accept that intelligence is not a single mountain to be climbed, but a vast, unexplored forest with many different paths. The silence of the rocks, therefore, may not be empty. It may be filled with the echoes of songs we cannot hear, and the shadows of wonders we cannot see, simply because we lack the context to understand them. Our search then becomes not just a geological investigation, but an exercise in expanding our imagination, in considering that the universe of mind may be far richer and more diverse than we have ever dreamed, and that our own technological frenzy may just be one way of being intelligent in a cosmos filled with quiet, forgotten possibilities. Let us now return our focus to the tangible, to the very minerals and elements that compose our world. For if a civilization, even one that followed a path different from our own, existed for any meaningful length of time, it would have necessarily interacted with the physical matter of its environment in ways that could leave a lasting, albeit subtle, imprint. The Earth's crust is a vast and complex library, and its books are written in layers of sediment, each page holding clues to the conditions of its time. Our task is to look for paragraphs that seem out of place, for sentences written in a grammar that does not match the natural prose of geology. We are searching for the unnatural, not in the sense of the supernatural, but in the sense of a concentrated order that is statistically implausible without a directing intelligence. One of the most promising places to look is in the record of rare earth elements and precious metals.
In nature, these elements are typically found widely dispersed. Their presence the result of slow, patient geological processes like fractional crystallization in cooling magma or hydrothermal vent activity. They appear in ores alongside other elements in predictable ratios. An industrial civilization, however, even a modest one, would seek to extract and purify these elements. The process of mining, refining, and utilizing them creates deposits of shocking purity and concentration. Imagine a layer in ancient rock that shows a sudden, incredibly dense band of platinum or iridium, metals that are extraordinarily rare in their pure form in nature. This band would not look like a natural ore vein. It would be a stark, abrupt anomaly, a signal of extraction and refinement that would stand out against the background noise of the geological record like a single, clear note held in a room of whispers. Similarly, the creation of synthetic materials, even simple ones, would leave a telltale signature. Plastics, for instance, are polymers that do not occur naturally. While our own plastic pollution is a blight on the modern world, from a geological perspective, it creates a unique and long-lasting marker. In 100 million years, the plastic debris of our age will have been broken down by mechanical forces into tiny pellets and fragments, but these will still be chemically distinct. They will form a persistent, global layer of microplastic particles in sedimentary rocks, a horizon that future geologists could point to as the moment a new type of chemistry, polymer chemistry, appeared on Earth. An ancient civilization might have developed its own suite of synthetic materials, perhaps from biological precursors or processed minerals, that would leave a similar strange chemical residue in the rocks of their time. We would also look for evidence of large-scale energy use. Our combustion of fossil fuels has already altered the carbon isotope ratio of the entire atmosphere, an alteration that is being recorded in the shells of marine organisms and in glacial ice. This isotopic spike is a clear global signal of a massive, rapid release of buried carbon. An earlier civilization might have used a different energy source, but any large-scale energy consumption that involves breaking chemical bonds or releasing stored energy would likely leave an isotopic anomaly of some kind. Perhaps we would find a layer enriched in a specific isotope of nitrogen from widespread biomass burning, or a strange shift in sulfur isotopes from an ancient form of energy production we haven't even considered. The search is for these sharp, geologically instantaneous deviations from the norm. Natural processes tend to be slow and gradual, creating smooth curves in the geochemical record. A civilization, by contrast, operates on a much faster timescale, and its impact would look like a spike, a step change, a sudden injection of something new and unusual into the Earth system. This is the quiet, patient work of planetary paleontology, not looking for bones, but for chemistry, not for structures, but for statistics. It involves drilling deep into ancient rock formations and subjecting them to the most sensitive analytical techniques, always with an open mind, looking for the one layer that doesn't fit, the one anomaly that whispers of a time when the world was different and someone, or something, was rearranging the pieces of the planet in a way that nature, left to its own devices, never would. It is a search conducted in laboratories as much as in the field, a
quest to read the subtle grammar of the elements themselves, listening for a sentence that was written not by the blind forces of geology, but by a mindful, purposeful hand. To deepen our search for a whisper from a deep-time civilization, we must turn to one of the most exquisite and delicate recorders of Earth's history, its ancient climate. The planet's atmosphere, its temperatures, and its composition are not constants. They are a dynamic symphony conducted by the sun, the oceans, volcanic activity, and the biosphere itself. These climatic variations are meticulously recorded in two primary archives: the layered sediments of the deep ocean floors, and, for more recent times, the ancient ice of glaciers and polar ice sheets. Within these natural vaults, we might find the most subtle and global evidence of all, a fleeting atmospheric signature of a civilization's presence. Consider the incredible resolution of an ice core. In places like Antarctica and Greenland, snow falls year after year, compressing under its own weight into ice. This ice traps tiny bubbles of the atmosphere from the time it fell. By drilling deep into these ice sheets, scientists can retrieve cores that act as a time machine, allowing them to analyze the exact composition of the air, including greenhouse gases like carbon dioxide and methane, from hundreds of thousands of years ago. Our own Industrial Revolution created a massive, unprecedented spike in these gases, a spike that will be perfectly preserved in the ice for future researchers to find. Now imagine if we found a similar, sudden spike in an ice core from 50 million years ago. It would be a stunning anomaly, a clear indication that something had rapidly released vast quantities of buried carbon into the atmosphere in a way that could not be explained by any known volcanic event or natural methane release. This would be perhaps the strongest possible chemical evidence for an industrial-like period in deep time. The challenge, of course, is that ice cores only preserve records for a limited time. The oldest continuous ice core record we have extends back only about 2 million years. Beyond that, the ice has flowed, deformed, and melted under pressure, erasing its ancient memories. For periods further back, we must rely on ocean sediments. The fossils of tiny marine organisms called foraminifera, which build their shells from elements in the seawater, record the isotopic and chemical conditions of the ocean in their calcium carbonate shells. When they die, these shells sink and become part of the sedimentary record. A massive, rapid release of carbon would acidify the oceans and leave a distinct carbon isotope excursion in these layers. Paleoclimatologists have indeed found several such excursions in Earth's deep past, the most famous being the Paleocene-Eocene thermal maximum, about 56 million years ago, when temperatures soared and the carbon isotope ratio shifted dramatically. The cause of the PETM is still debated, with most scientists attributing it to massive volcanic activity or the release of methane clathrates from the ocean floor. But the point is, the signal is there. The method exists. To search for a civilization, we would need to examine these known excursions with a new question in mind. Does the chemical signature look purely natural, or does it contain hallmarks of something more refined? For instance, the burning of fossil fuels releases specific types of carbon compounds and is accompanied by other pollutants. A natural methane release would have a different isotopic signature than the controlled combustion of biomatter by an intelligent species. It is a needle in a haystack, requiring us to reanalyze these ancient climate events with incredible precision, looking for traces of synthetic molecules or unusual metal concentrations that might have been aerosolized and spread globally. The absence of such evidence in these known events is, again, not proof of absence. It might simply mean that if a civilization existed, it did not undergo an industrial revolution based on combustion. Their energy signature might have been thermal, chemical, or biological, leaving a much fainter, more ambiguous mark on the global climate system. Their greatest impact on the planet might have been through land use change, widespread agriculture or deforestation, which could also leave a carbon isotope signature, though one that would be harder to distinguish from natural changes in vegetation and soil carbon cycles. This search is therefore a testament to the patience of science. It requires us to listen to the very faintest notes in the symphony of Earth's climate history, to discern whether one of those notes was played by an external hand, or whether the entire magnificent and complex composition is the work of the planet alone, a solo performance across the deep, deep time of the ages. As we journey deeper into this contemplative exploration, we inevitably arrive at a point not just of scientific inquiry, but of profound philosophical reflection. The enduring silence of the rocks, the absence of any clear, undeniable evidence for a prior civilization, speaks volumes in its own quiet way. It leads us to a humbling and strangely peaceful consideration that we may indeed be the first. Our species, with its fleeting moment of self-awareness and technological frenzy, may be the first entity in the 4.5 billion-year history of this planet to look up at the stars and wonder about its own place in the cosmos, to develop the language of mathematics and physics to understand it, and to develop the tools to alter the very planet on a geological scale. This is not a statement of arrogance, but one of immense and sobering responsibility. It suggests that the great experiment of technological intelligence, at least on this world, is a novel event. We are living through its earliest, most fragile stages. This realization casts our current environmental crisis in a new, longer light. The geological layer we are creating right now, the Anthropocene, with its spikes in radioactives, microplastics, and altered isotope ratios, may not just be another transition in Earth's history. It may be the first of its kind, a unique and permanent signature that will be legible in the rocks for epochs to come. We are writing the opening paragraph of a completely new chapter in the planet's biography, one that introduces a new force of nature, a conscious, planet-altering intelligence. The possibility of a prior civilization, even if ultimately unproven, serves as a poignant thought experiment for our own future. If a civilization did rise and fall long ago, what was its fate? Did it succumb to the very changes it wrought upon its environment, a victim of its own success? Did it achieve a sustainable balance and eventually choose to, or simply evolve to, leave a lighter footprint, fading so gracefully back into the ecosystem that it left no trace we could find? Or did it transcend its biological form and its planetary home entirely, moving on to other realms and leaving behind a world scrubbed clean of its artifacts? These are not just scientific questions. They are mirrors we hold up to our own potential futures. The search for them, even if it finds nothing, forces us to confront the longevity of our own legacy. What will remain of us in 100 million years? Our cities will be gone, compressed into thin layers of strange sediment. Our greatest monuments will be dust. Our libraries and digital records will have long since decayed into nothingness. The most enduring marks will be the chemical ones, the radioactive layer, the plastic particles, the fossilized gullies where we strip-mined entire landscapes, and the abrupt shift in the types of fossils found, marking a mass extinction event we precipitated. We will be identified by our waste, by our scars. This is a calming thought in its own way. It reminds us of the transient nature of all things, even our most towering achievements. It suggests that the true value of a civilization may not be in the durability of its physical constructs, but in the quality of its existence, in the beauty it created, the knowledge it discovered, and the ethical choices it made while it flourished. The emptiness we find when we look back may be a gift. It is a blank page. It means that the story of intelligence on Earth is still being written, and we are its authors. The immense pressure of being the first is also an immense privilege. It grants us the opportunity to choose what kind of signature we leave behind, whether it will be a glaring scar of carelessness or a gentle, elegant layer that speaks of a species that learned to live in harmony with its world, that cherished its moment in the sun, and that perhaps one day even learned how to bow out gracefully, leaving the stage clean for the next act in Earth's endless, wondrous play. This silent past is not a void, but a canvas, and our present is the brush with which we are painting upon it. In our serene journey through deep time, we must now turn our attention to the most dramatic events in Earth's biological history, mass extinction events. These are the great resets, the moments where the tapestry of life was violently unraveled, only to be slowly rewoven into new and often unexpected patterns. There have been 5 major such events in the past, and many smaller ones, each leaving an indelible mark in the fossil record. From a certain perspective, these events represent the closest thing we have to a global signature, a planetary scale phenomenon that could, in theory, conceal or reveal the presence of a civilization. Could one of these cataclysms have been caused not by an asteroid impact or massive volcanism, but by the actions of an advanced species? It is a haunting thought. Our own species is currently believed to be initiating a 6th mass extinction through habitat destruction, pollution, and climate change. The fossil record of the future will show a sudden, catastrophic drop in biodiversity, particularly among large mammals, followed by a rapid rise of opportunistic species that thrive in disturbed environments, a pattern not unlike some past extinctions. If we can do this in a mere few centuries, could a prior civilization have done the same over a longer period? The challenge, of course, is that the natural causes of mass extinctions are themselves utterly devastating. The end Cretaceous event, which wiped out the dinosaurs, was triggered by an asteroid impact that left a global layer of iridium and caused decades of global winter. The end Permian event, the Great Dying, was likely caused by colossal volcanic eruptions in Siberia that poisoned the atmosphere and oceans. The signals of these events, iridium spikes, mercury anomalies, carbon isotope excursions, are stark and clear in the rock record. But they are also perfectly explainable by natural astrophysical and geological processes.
To attribute one to a civilization, we would need to find an anomaly within the anomaly. For instance, an iridium spike from an asteroid impact is a single sharp pulse. An iridium spike caused by widespread industrial use and dispersal might be a more prolonged signal, or it might be accompanied by other refined metals in unnatural ratios. A climate change event caused by volcanism has a certain geochemical fingerprint. One caused by the deliberate or accidental release of greenhouse gases might have a slightly different one, perhaps with traces of synthetic compounds or combustion byproducts that shouldn't exist. But herein lies the profound fragility of biological evidence. Even if a civilization triggered its own downfall through environmental collapse, the evidence would be swiftly overwritten by the extinction event itself. The subsequent millions of years of erosion, sedimentation, and ecological recovery would bury the cause under layers of new rock and new life. The signal would be ambiguous at best. The fossils would tell a story of death and renewal, but the cause of death would remain a mystery, just as the exact triggers for many past extinctions are still debated today. Furthermore, a civilization that fell victim to such a collapse would likely leave little behind. Its population would crash, its infrastructure decay, and its knowledge vanish. Within a few thousand years, the forests and oceans would reclaim its cities. Within a few million years, the grinding plates of the Earth would recycle the very continents it stood upon. All that might remain is that subtle chemical whisper in the sedimentary layer marking the extinction. A whisper that could easily be mistaken for a natural disaster. This leads us to a somber, almost poetic conclusion. The most likely way for a civilization to leave a lasting mark is through its own demise. To be visible across 100 million years, a species might need to have made a mistake so catastrophic that it altered the entire planet's evolutionary trajectory. Its legacy would not be one of achievement, but of warning. A faint echo of a failure written in the language of fossils and isotopes. This gives our own current situation a deep, resonant gravity. We are, right now, creating a geological layer that will be read by whatever intelligence, terrestrial or otherwise, that examines this planet in the distant future. The question is, what story will it tell? Will it tell a tale of a brief, fiery bloom of intelligence that burned too brightly and consumed itself? Or will it tell a more nuanced story of a species that learned to understand its power, that weathered a crisis, and that found a way to persist, leaving a gentler, more sustainable signature on its homeworld? The silent past does not answer this question. It only watches,
patiently as we write the answer with every choice we make. To understand the profound silence we encounter when gazing into the deep past, we must fully appreciate a fundamental geological truth. The Earth suffers from a permanent and all-encompassing case of amnesia. This is not a metaphor for lost records, but a physical process of constant renewal and erasure. The very crust upon which we walk, the stage for all of life's drama, is transient. Over spans of time that dwarf human comprehension, the entire surface of the planet is recycled, melted, and rewritten. Geologists call this the rock cycle, but on a planetary scale, it functions as a mechanism of forgetting, a slow, inexorable process that ensures almost nothing of the distant past remains in its original form. This concept, sometimes termed lithospheric amnesia, is the single greatest obstacle to finding evidence of any deep-time civilization. The oceanic crust, which makes up the majority of the Earth's surface, is particularly ephemeral. It is constantly being created at mid-ocean ridges and then destroyed, subducted back into the fiery mantle and deep ocean trenches. No oceanic crust older than about 200 million years exists because it has all been consumed and recycled. This means that any civilization that lived on or near a coast, which most do, would have had its physical artifacts carried on a conveyor belt of rock into the planet's interior to be melted and erased forever. If an advanced culture built glorious cities along the shores of an ancient sea, those lands now lie at the bottom of the Earth's mantle, their substance converted into magma. The continental crust is older and more permanent, but it is not immune.
While continents can be billions of years old, their surfaces are constantly being eroded and reformed. The Appalachian Mountains, once taller than the Himalayas, have been worn down to gentle hills over 300 million years. The sediments that were scoured from them now form new layers of rock far away. A structure sitting on the surface, even one made of stone, has a lifespan measured in mere millions of years before it is ground down to sand by wind, rain, ice, and biological activity. Furthermore, the continents themselves are not static. They drift, collide, and break apart in the great dance of plate tectonics. A continent that was once at the equator may now be at the pole. A vast inland sea may have become a desert plateau. The very stage upon which a deep-time civilization would have played out has been utterly rearranged. We are not just looking for a needle in a haystack. We are looking for a specific piece of hay in a stack that has been burned, turned into paper, printed into a book, and then burned again, countless times over. This relentless recycling extends to the fossil record itself. The layers of sedimentary rock that hold the fossils of ancient life are themselves only temporary archives. They are uplifted by tectonic forces and then exposed to the elements, where they are eroded away. Their sediments are then carried by rivers to new locations to form new rocks, in a process that can scramble and mix fossils from different eras. The fossil record is therefore not just incomplete, it is a palimpsest, a parchment that has been scraped clean and written over again and again, with only faint, ghostly traces of the original writing remaining. This is why the search for a prior civilization cannot be a search for physical structures. It must be a search for the most resilient and diffuse of signals, synthetic molecules that could withstand being weathered and redeposited, isotopic anomalies that could survive the melting of rocks, or perhaps the most subtle evidence of all, a strange and unexplained gap in the natural progression of life, a missing link in evolution that suggests not a failure of preservation, but an external influence that was itself erased. The piece that comes from understanding lithospheric amnesia is the piece of accepting impermanence. It tells us that the Earth is a living, breathing entity that remembers only in broad strokes: the rise of oxygen, the march of glaciers, the fall of asteroids. The delicate details, the stories of individual lives, and perhaps even entire cultures, are lost to the deep,
warm rock below. Our own cities and achievements will one day share this fate. This is not a cause for despair, but for a quiet, profound humility. We are fleeting guests on a dynamic world, and our time to make our mark, to tell our story, is brief. But within that brevity lies its own beauty and urgency, a reminder to cherish our moment in the sun, for the stage itself is constantly shifting, and tomorrow's performance will always be on new ground. In the face of Earth's relentless recycling of its surface, our search for a prior intelligence must focus on the most stubborn, the most resilient fragments of potential technology. Materials so durable that they could theoretically survive the crushing pressures, scorching temperatures, and abrasive forces of tens of millions of years. These would not be the grand structures of a civilization, but its microscopic, almost indestructible waste products. We are looking for the geological equivalent of a single, incredibly tough tooth in a long vanished body, a technological fossil. Our own civilization provides the blueprint for what these might be. Consider ceramics. Certain advanced ceramics, like those used in industrial applications or aerospace, have extremely high melting points and are highly resistant to chemical weathering. A fragment of a refined ceramic component, perhaps from a high-temperature process, could potentially survive being buried, subducted to moderate depths, and then re-emerged in a new rock formation. It would appear as a bizarre, anachronistic inclusion in ancient stone, a piece of material with a crystalline structure and purity never found in nature. Or consider glass. While ordinary glass deteriorates over time, certain synthetic glasses, or glassy slags produced as a byproduct of high-temperature metallurgy, can be very persistent. They could be transported by rivers, eventually ending up in sedimentary deposits, where their unusual composition and conchoidal fracturing would mark them as artificial to a trained geologist. They would be like tiny, hardened tears from a forgotten industry. But the most promising candidates are refined metals. Nature does not produce pure manufactured metal objects. It produces ores, rocks where metals are chemically bonded with other elements. An ancient civilization would have smelted these ores to extract pure copper, tin, iron, or even more exotic metals. A nugget of 99% pure copper, or a fleck of stainless steel, an alloy of iron, chromium, and nickel, found in a stratum dating back 100 million years would be a discovery of earth-shattering proportions. It would be unambiguously artificial. The challenge, of course, is that even these durable materials are subject to the planet's destructive forces. Metal corrodes. It oxidizes and returns to a more natural mineral state. A steel beam left exposed will eventually become a rust stain, a deposit of iron oxide. To survive, a metal artifact would need to be deposited in an environment devoid of oxygen, perhaps buried deep in an anoxic clay or sealed in a cave, and then never subjected to the heat and pressure of significant tectonic activity. It would need to be incredibly lucky. The search, therefore, becomes one for extreme statistical outliers. It would involve methodically processing massive volumes of ancient sedimentary rock, carefully crushing it, and using sensitive chemical and physical methods to look for a single, anomalous grain that shouldn't be there. It is a task of monumental patience, like sifting every grain of sand on a vast beach in the hope of finding one that is perfectly square. This is why such a discovery has never been made. Not because it's impossible, but because the scale of the search is so vast and the likelihood of preservation so vanishingly small. Yet, the possibility remains, a tiny, gleaming shard of chance. And if such a thing were ever found, it would force an instantaneous and breathtaking rewrite of history. It would be the ultimate message in a bottle, washed up on the shore of time from a sea we never knew existed. It would tell us only one thing for certain. We were not the first. But it would tell us nothing of who they were, what they dreamed, or why they vanished. It would be a solitary, silent witness to a world lost to the amnesia of the rocks, a single, enduring word from a language we can no longer understand. This quiet possibility that a single, indestructible speck of something made might still be out there, waiting in the darkness of deep time, adds a layer of profound wonder to the study of geology. Every stone we pass, every cliff face we see becomes a potential archive, not just of natural history, but of a story that, just maybe, has yet to be read. Given the immense challenges posed by lithospheric amnesia, the constant recycling and reshaping of Earth's surface, our search for any whisper of a deep-time civilization must logically turn to the most stable, ancient, and undisturbed places on the planet. These are the geological sanctuaries that have escaped the planet's relentless renewal, the quiet corners where time's passage is recorded in slow, patient layers rather than in violent upheavals and erasures. To find a preserved signal, we must look to the shields and cratons, the primordial hearts of the continents that have remained relatively unchanged for billions of years, and we must consider the possibility of evidence that was buried deep enough to be protected, but not so deep as to be transformed by heat and pressure. The oldest and most stable parts of the continents are known as cratons. These are thick, buoyant blocks of crust that have largely avoided being pulled apart by tectonic forces or subducted back into the mantle. Places like the Canadian Shield, the Australian outback, and parts of South Africa and Scandinavia contain rocks that are over 3 billion years old. Their surfaces are often characterized by vast, flat expanses of ancient igneous and metamorphic rock, but crucially, they also contain pockets of sedimentary basins that have remained intact for extraordinary lengths of time. These basins are like time capsules. They were formed when the cratons subsided slightly, creating a depression that slowly filled with layer upon layer of sediment over millions of years. Because the craton itself is so stable, these sedimentary layers have often been spared from the folding, faulting, and metamorphism that disport the rock record in more active regions. They have simply sat there, accumulating dust, pollen, ash, and chemical signals from the atmosphere and water, creating a continuous, pristine record of their time. It is within these ancient, stable basins that we might have the best chance of finding a preserved chemical anomaly. If a civilization existed hundreds of millions of years ago, and if it created a global atmospheric signal, a pulse of unusual gases, a spike in particulate pollution, a release of synthetic compounds, that signal could have been captured in the mud at the bottom of a quiet lake or a shallow sea within one of these cratonic basins. The mud would have hardened into shale, sealing the chemical evidence inside. The subsequent layers would have buried it gently, protecting it from erosion. The stability of the craton would have ensured it was never cooked or twisted into something unrecognizable. We could, in theory, drill a core into such a formation today and, using incredibly sensitive mass spectrometers, analyze the chemistry of the ancient air and water trapped within the rock's microporosity, looking for a spike that shouldn't be there. Another, more speculative possibility lies in the deep subsurface. We know that life exists kilometers below the Earth's surface, in the deep biosphere of rocks and fluids. Could a civilization have ventured there, perhaps for resource extraction, energy, or sanctuary? And if so, could they have left behind evidence that was protected from the surface world's destructive cycles? Tunnels or excavations, unless they were monumental and lined with incredibly durable materials, would have collapsed over millions of years. But what they might have left behind could be more subtle. A localized alteration in the chemistry of deep groundwater, an anomalous concentration of metals around a deep thermal vent they might have tapped, or even a strange isolated fossil record of microbial life that had been influenced by their presence. The rocks of the deep subsurface are isolated from the surface, but they are not static. They are part of slow-moving hydrological and geochemical cycles. An artificial signal here would be incredibly difficult to find, and even harder to interpret, as we still know so little about the natural chemical rhythms of this deep world. The search in these stable regions is not one of dramatic excavation, but of meticulous, patient science. It involves poring over existing geological surveys to identify the most promising, undisturbed sedimentary sequences. It requires obtaining deep core samples, which is a costly and complex endeavor. And then it demands the painstaking analysis of those samples, layer by microscopic layer, with the most advanced analytical tools available, all while knowing that the chance of finding anything is infinitesimally small. It is a testament to human curiosity that such a search is even conceivable. This methodical approach transforms our quest from a fanciful speculation into a legitimate, if fringe, scientific investigation. It is the process of listening to the oldest, quietest parts of the planet with a stethoscope of immense sensitivity, hoping to detect a single, faint, and irregular heartbeat from a time before memory, a whisper from a world that the Earth itself has almost completely forgotten. It is a peaceful, patient form of archaeology where the dig site is 1 billion years old and the size of a continent, and the treasure is not gold, but knowledge. As we delve ever deeper into this tranquil inquiry, we must pause to consider the very foundations of our search. Our investigation is framed by a single, powerful question. Could an advanced civilization have lived on Earth millions of years ago? But to answer this, we must first gently unpack the words we use. What do we truly mean by advanced? What constitutes a civilization? And what defines technology? These are not merely semantic exercises, they are essential to expanding our imagination beyond the narrow confines of our own human experience. From our anthropocentric viewpoint, we often envision advancement as a linear path leading towards something that looks familiar. Cities, agriculture, metallurgy, industrialization, and digital networks. We measure progress by energy consumption, material complexity, and control over the environment. This is the trajectory of Homo sapiens, but it is not necessarily the only one possible. It is a path born from our specific biology, our grasping hands, our omnivorous diet, our vocal cords, and our peculiar blend of cooperation and competition. Another intelligent species, evolving from a different evolutionary branch, perhaps cephalopods, corvids, or a long-vanished lineage of social reptiles, might have developed a concept of advancement that is utterly alien to us. Their civilization might not have been built on concentrated settlements, but could have been a vast, decentralized network, a symbiotic relationship with a forest or reef system that spanned a continent.
Their greatest technological achievements might not have been in physical constructs, but in biochemical mastery. Engineering life forms to perform tasks, creating complex communication through pheromones or bioluminescence, or developing a deep, intuitive understanding of ecological systems that allowed them to thrive without ever needing to mine or smelt. Their technology would have been living technology, biodegradable and seamlessly integrated into the natural world. After 50 million years, what would remain? The engineered life forms would have either gone extinct or evolved beyond recognition, their design traits disappearing into the background of natural selection. The chemical signals of their communication would have dissipated into the atmosphere and oceans eons ago. Their existence would have been a whisper in the wind, leaving no more trace than a particularly complex and stable natural ecosystem. This challenges our search parameters completely. We are looking for stone, metal, and plastic, but what if their legacy was a persistent, anomalous distribution of certain pollen types in the fossil record, suggesting a cultivated plant that no longer exists? What if it was a strange, brief period of extraordinary stability in a certain ecosystem, a harmony that seems too perfect to be natural? We would likely dismiss these as interesting curiosities, not evidence of intelligence, because our definition of intelligence is inherently tied to material manipulation. Furthermore, the concept of a civilization implies collective learning and the transmission of knowledge across generations.
For humans, this is achieved through language and writing. But another species might have developed a completely different method. What if knowledge was stored genetically, passed down through DNA in a form of Lamarckian evolution we cannot yet conceive? What if their history was encoded in complex songs, dances, or migratory patterns that left no physical fossil? The evidence for such a culture would be virtually non-existent in the geological record. It would be a story told only in the moment, a performance that ended with the last performer. This perspective is not a dismissal of the search, but an expansion of it. It asks us to practice a form of intellectual humility, to let go of our human-centric assumptions, and consider that the universe of possible intelligences is far vaster and more strange than we can imagine. The silence we encounter may not be empty. It may be filled with the echoes of songs we cannot hear, and the shadows of wonders we cannot see, simply because we lack the context to understand them. Our search, therefore, becomes not just a geological investigation, but an exercise in expanding our imagination. It is a quiet meditation on the diversity of consciousness and the many forms that a mindful relationship with a planet can take. The greatest discovery might not be a piece of refined metal in ancient rock, but a realization that advancement is not a destination, but a direction, and that there are countless paths a species might take, most of which leave no permanent mark on the stone of their world, but perhaps a more beautiful and more transient mark on its life. Beyond the geological and biological evidence, there is a deeper, more introspective layer to our quest, a quiet exploration of why the idea of a lost, advanced civilization holds such a powerful grip on the human imagination. It is a notion that appears in our myths and stories, from the sunken city of Atlantis to tales of ancient, godlike beings. This persistent fascination is not merely a flight of fancy, it speaks to something fundamental within us, a longing to find meaning in the vastness of time, a desire to feel that we are part of a larger story, and perhaps a subtle fear of our own impermanence. Contemplating the deep past can be a lonely exercise. The sheer scale of geological time, with its billions of years of seemingly empty silence before our arrival, can make our own existence feel like a fleeting, insignificant accident. The idea that we might not be the first intelligent species to gaze at the stars offers a comforting sense of continuity. It suggests that intelligence and perhaps even technological ambition are not flukes, but potential outcomes of evolution itself. Phenomena that might arise given enough time and the right conditions. In this light, we become part of a lineage, even if that lineage is separated by uncountable generations. Our struggles, our achievements, and our questions about the universe would not be entirely new. They would be the latest iteration of a deep time conversation. This thought carries a certain melancholy solace, softening the edge of our cosmic loneliness. Furthermore, the concept serves as a profound metaphor for our own future. The possibility of a civilization that rose and fell long ago holds up a mirror to our own trajectory. It forces us to confront the potential fragility of our own achievements. Could we, too, become nothing more than a thin layer of strange chemicals in the rock? A mystery for some future intelligence to ponder. This is not a thought designed to frighten, but to inspire perspective and perhaps humility. It encourages us to think about the legacy we are creating right now, not just our physical waste, but the cultural and ethical marks we leave on the planet. What would we want that legacy to be? The search itself, regardless of its outcome, is also a testament to a beautiful human quality, boundless curiosity. It represents a refusal to accept that the story is fully known, a willingness to look at familiar evidence, a layer of rock, a fossil assemblage, an isotopic ratio, and ask a new, heretical question. Could this mean something else? This is the essence of scientific exploration. It is a peaceful, persistent curiosity that drives us to sift through the sand of ages, not because we are certain we will find a treasure, but because the act of looking is itself a form of reverence for the mysteries of our world. It is a way of paying attention to the quietest parts of the planet's history, of listening for a whisper that almost certainly isn't there, but which, if it were, would change everything. On a psychological level, the idea also touches on a universal human experience, the desire to uncover hidden truths and solve mysteries. It transforms the entire Earth into a puzzle box, every cliff face and canyon into a potential clue. This romanticizes the field of geology, infusing it with a narrative drive that goes beyond the academic. It makes the study of deep time not just a science, but a form of storytelling, where we are the detectives trying to reconstruct a plot from which most of the pages have been torn out. Ultimately, whether such a civilization existed or not may be less important than the questions the possibility raises within us. It invites a quiet meditation on time, memory, and loss. It asks us what it means to exist, to create, and to vanish. And in doing so, it helps us define what we value about our own existence here and now. The deep past becomes a canvas onto which we project our hopes, our fears, and our profound sense of wonder at the beautiful, mysterious planet we call home. The silence of the rocks is not an emptiness to be filled, but a space for contemplation. As we continue our serene investigation, we must turn a gentle yet discerning eye toward the known geological record, not to rewrite it, but to quietly ask if any of its existing mysteries and anomalies could be viewed from a new, albeit speculative, perspective. The history of Earth science is filled with discoveries that were initially puzzling, oddities that challenge prevailing theories until careful research revealed a natural, if extraordinary, cause. Could it be that within this catalog of enigmas, there lies a clue that has been misclassified, not through any error, but simply because an alternative explanation was never considered necessary? Let us consider, for instance, the phenomenon of certain metal deposits. Nature produces metal ores through slow, thermochemical processes that result in specific mineral associations and isotopic distributions. But what if we were to find a deposit that defies these patterns? A concentration of nickel or chromium so pure, so isolated from its expected geological context, that it resembles an industrial stockpile more than a natural vein. Geologists would rightly seek a novel, natural process to explain it. But the remote possibility remains that they might be looking at the mineralized ghost of a warehouse, its contents transformed by time, but still holding a shape that whispers of organization rather than random accretion. Another example lies in certain sedimentary layers that show a sudden, inexplicable increase in complexity. The fossil record occasionally presents what paleontologists call a burst of innovation, a relatively short period in which new body plans and species appear with surprising rapidity. The Cambrian explosion is the most famous of these. The standard explanation involves rising oxygen levels and an evolutionary arms race. But could there be a more exotic, if far less likely, contributor? What if an external influence, an intelligent force, somehow played a role in guiding or accelerating this process? It is a notion that sits far outside mainstream science, but it serves to stretch our imagination. The evidence would not be a fossilized tool, but perhaps a pattern in the fossil record that suggests a directed manipulation of an ecosystem, a statistical aberration in the rate of morphological change that is difficult to attribute to natural selection alone. Then there are the mysterious gaps in the record themselves. The Romer's Gap, a period in the early Carboniferous period, about 360 million years ago, shows a curious scarcity of tetrapod fossils. It represents a time when vertebrate life was supposedly making its crucial transition from water to land. The gap is slowly being filled with new discoveries, but what if its persistence hints at something else? Could it represent a period of environmental instability caused by a factor not yet considered? Again, this is not to propose a civilization caused a gap in the fossil record, but rather to use such mysteries as a canvas for our contemplation. What kind of global event could create such a silence? If a civilization were to collapse in a way that drastically altered planetary conditions, could it create a temporary pause in the formation of fossils that could be preserved? The most valuable outcome of this reevaluation is not the discovery of evidence for a lost civilization, but the cultivation of a certain quality of attention. It is the practice of looking at the natural world with a sense of openness to its deepest mysteries. It encourages scientists and curious minds alike to not just accept anomalies as puzzles to be solved within the current paradigm, but to occasionally, quietly, ask if the paradigm itself might be incomplete. This does not mean abandoning scientific rigor. It means complementing it with boundless imagination. It is the difference between looking at a strange rock formation and seeing only a curious product of erosion, and allowing oneself to momentarily wonder, what if it were something else? The first approach gives us correct science. The second, though far more likely to lead nowhere, keeps our sense of wonder alive. It ensures that our study of the deep past remains not just a technical discipline, but a deeply human one, filled with the potential for breathtaking discovery. For even if we never find a single piece of evidence for a prior civilization, the act of looking with such care and curiosity will undoubtedly lead us to a richer, more nuanced understanding of the natural world. We will discover new geological processes, uncover new details about past extinction events, and gain a deeper appreciation for the incredible, dynamic history of our planet. The search itself, therefore, becomes a rewarding journey, a peaceful and profound meditation on the secrets that time has kept and the stories the Earth is still waiting to tell. To deepen our search for a whisper from a deep-time civilization, we must turn our attention to the most resilient and ubiquitous of life's forms, plants. While animal fossils are rare and fragile, the fossil record of plant life is remarkably rich and continuous, preserved in the form of coal seams, petrified wood, and most importantly, pollen. Paleobotany, the study of ancient plants, and palynology, the study of pollen and spores, offer a uniquely subtle and persistent window into past ecosystems. If a civilization existed that practiced agriculture on a significant scale, its most enduring legacy might not be in stone or metal, but in the very pollen and seeds it cultivated and dispersed. This evidence would be fragile and diffuse, but unlike a city or a tool, it would be replicated millions of times over, scattered across continents by wind and water, and preserved in the mud of ancient lakes and wetlands that slowly hardened into stone. Imagine the evidence we are leaving today. Modern industrial agriculture creates a massive global signature. The pollen from our vast monoculture farms, endless fields of corn, wheat, and soy, will form a distinct, sudden layer in future sedimentary rocks. It will show an overwhelming dominance of a few plant species, a sharp decrease in pollen diversity, and a geographic distribution that bears the unmistakable fingerprint of human planning and cultivation, not natural dispersal. Furthermore, the plants themselves are genetically modified, and while the DNA itself would not survive millions of years, the morphological changes we've bred into them, larger seeds, specific shapes, altered structures, might be preserved in the fossil record. Now, transpose this thinking to a deep-time context. What would we be looking for? We would be searching for a similar anomaly in the ancient pollen record. A layer in strata from, say, the Carboniferous period that shows a bizarre, geographically widespread dominance of a single species of plant pollen, a species that is otherwise rare or unknown in earlier or later layers. This would suggest that this plant was not just thriving naturally, but was being deliberately and extensively cultivated, its natural competitors removed, and its habitat managed on a continental scale. We would look for evidence of what paleoecologists call disturbance species, plants that typically colonized cleared land, like ferns or certain fast-growing shrubs. A prolonged period showing a high prevalence of these species' pollen could indicate widespread land clearance, perhaps for agriculture or settlement, that was maintained for centuries or millennia. Another clue might be found in the fossilized remains of the plants themselves. If a civilization selectively bred plants for larger fruit or more durable grains, we might find fossils of these cultivated plants that show morphological features outside the natural range of variation for their wild ancestors. A seed pod, unusually large for its family, or a grain with a strangely thickened husk could be a hint of artificial selection at work. Of course, the challenge is immense. The natural world itself creates monocultures. Dense stands of a single tree species can dominate a landscape for long periods. A wildfire can clear vast tracts of land, leading to a burst of disturbance species in the pollen record. Distinguishing a natural event from a sustained agricultural practice requires looking at multiple lines of evidence over a long period. Was the shift to a single pollen type abrupt and maintained consistently for a long time? Is it associated with other markers, like increased charcoal from controlled burning, or strange soil layers that suggest erosion from tilled land? The null hypothesis will always be a natural cause, but the possibility remains that one of the many unexplained anomalies in the plant fossil record, a sudden shift in dominance, a strange distribution, an oddly modern-looking seed in a very ancient rock, could be the ghost of a field that was planted and harvested by hands that vanished eons ago. This search requires a particular kind of patience. It involves the meticulous counting of thousands of microscopic pollen grains under a microscope, comparing their shapes and frequencies across different layers and locations. It is a slow, quiet science, a form of botanical archaeology performed on a geological timescale. It may never yield proof of a civilization, but it attunes us to the subtlest rhythms of the ancient Earth. It teaches us to read the landscape not just as a story of climate and evolution, but as a potential record of care and cultivation, a testament to the possibility that long before us, other beings may have also nurtured the soil, tended to plants, and in doing so left a faint, almost invisible signature of their passage written not in stone, but in the golden dust of pollen, waiting for a curious mind to read it. As we venture further into this contemplative exploration, we must attune our senses to even more subtle frequencies of evidence, moving beyond physical shapes and into the realm of elemental ratios and atomic signatures. The very atoms that make up our world carry a hidden history within them, specifically in the form of stable isotopes, variants of elements that have different numbers of neutrons and those slightly different weights. Natural processes fractionate these isotopes in predictable ways, creating a baseline of isotopic ratios in the atmosphere, oceans, and rocks. A civilization, however, by engaging in large-scale manipulation of its environment, would inevitably alter these ratios, creating anomalies that could persist in the geological record long after every physical artifact has vanished. This is where we search for the chemical ghost of large-scale energy use and land management. Our own civilization is creating a massive isotopic excursion right now. The burning of fossil fuels releases vast quantities of carbon that has been buried for millions of years. This ancient carbon is depleted in the heavier carbon-13 isotope relative to the lighter carbon-12. As we pump this old carbon into the atmosphere, we are shifting the global ratio in a downward direction, a signal that is being recorded in tree rings, coral skeletons, and glacial ice, and will eventually be preserved in sedimentary rocks. This is a clear, global technosignature. An ancient civilization might have used a different energy source, but any large-scale combustion of biomass, whether for clearing land, for warmth, or for industry, would leave a similar, though potentially smaller, carbon isotope anomaly.
A sustained period of widespread fire would pump light carbon from burned plants into the atmosphere, which would then be taken up by the oceans and incorporated into the shells of marine microorganisms. A geologist analyzing a core of ancient limestone might find a sudden, sharp negative excursion in delta 13C values, a period where the shells of foraminifera became significantly richer in light carbon. While such excursions are known in Earth's history and are usually attributed to massive volcanic events or the release of methane clathrates, a key would be to look for corroborating evidence. Does the excursion coincide with a spike in charcoal particles in the sediment, indicating widespread fire? And does the pattern of the excursion suggest a rapid, pulsing release of light carbon, as might occur from deliberate, repeated burning, rather than a single catastrophic natural event? Beyond carbon, we can look to nitrogen. The development of agriculture involves fixing nitrogen from the atmosphere into the soil, either through cultivating legumes, or, in a more advanced scenario, through industrial processes like the Haber-Bosch method. This dramatically alters the nitrogen cycle and changes the isotopic composition of nitrogen in soils and nearby water bodies. A sudden, sustained shift in nitrogen isotope ratios, delta 15N, in ancient sedimentary rocks could indicate a period of intensified agricultural activity or even something akin to primitive fertilizer use. This signal would be more localized than a global carbon excursion, making it harder to find, but also more directly tied to the footprint of a settled farming society. The evidence would be incredibly diffuse. It would not be an object, but a statistical pattern etched into the chemistry of rock formations. To detect it, we would need exceptionally well-preserved sedimentary sequences that allow for high-resolution sampling, the ability to see changes that occurred over decades or centuries, not just millennia. We would need to rule out every possible natural cause, from changes in ocean circulation to the evolution of new photosynthetic pathways in plants. The search, therefore, becomes one of exquisite analytical precision. It is performed not with shovels and brushes, but with mass spectrometers and laser ablation systems, instruments capable of measuring isotopic ratios in parts per thousand from the microscopic samples. It is a quiet, meticulous form of detective work, a process of listening to the faintest echoes of chemical processes that unfolded under an alien sun. Even if we never find such an anomaly that defies natural explanation, the act of looking enriches our understanding. It forces us to model the Earth's geochemical cycles with greater precision. It makes us better understand how natural events like volcanism can mimic the signals we might attribute to intelligence. And it leaves us with a profound appreciation for the subtlety of the traces we ourselves are leaving. Our own civilization's signature is not just in our skyscrapers, it is in the very atoms of the air, a chemical whisper that will linger in the rocks long after our cities have turned to dust, telling any future entity that we were here, that we burned, that we built, and that we changed the world. In our serene pursuit of whispers from a deep-time civilization, we must expand our gaze beyond the sunlit landscapes and consider the possibility that evidence, if it exists, might be hidden in the most stable and protected environments on Earth, the deep subsurface and the abyssal plains of the ocean floor. These realms, largely isolated from the violent surface processes of erosion and tectonics, offer a tantalizing, though immensely challenging, possibility for preservation. They represent the planet's deepest vaults, where time moves with a different, more ponderous rhythm, and where the chaotic recycling of the surface gives way to a profound and enduring stillness.
The deep subsurface, the world of rock and groundwater extending kilometers below our feet, is a frontier we are only beginning to understand. It is not a dead zone, but a vast, dark biosphere teeming with microbial life that exists independently of the sun's energy. If a civilization sought longevity, stability, or perhaps refuge from surface catastrophes, it might have ventured into this realm. The challenges of finding evidence here are astronomical. Any structure not built with truly eternal materials would have been crushed, dissolved, or deformed by the immense pressures, chemical reactions, and slow plastic flow of rock over millions of years. Tunnels would collapse, chambers would be sealed. However, the evidence we might search for would not be a recognizable structure. It could be a chemical anomaly, a localized concentration of metals or rare earth elements that suggests refined materials were brought to depth, perhaps for a purpose we cannot fathom.
It could be an isotopic signature in ancient groundwater, a pocket of fluid that has been isolated for millions of years, showing an unusual ratio of noble gases, or a trace of synthetic compounds that have no business being so deep. It could even be a bizarre fossil assemblage, a colony of extremophile microbes whose genetics or distribution suggest they were once nurtured or engineered by an intelligence that sought to store information or energy in a biological form. Proving such a thing would be nearly impossible, as it would require distinguishing an artificial signature from the incredibly strange but natural chemistry of the deep Earth. The deep ocean floor presents a different kind of promise. Large areas of the abyssal plains are among the most stable and undisturbed places on Earth. They are deserts of fine sediment that accumulate at an achingly slow pace, layer by delicate layer, preserving a continuous record of whatever particles drift down from the world above. If a civilization conducted large-scale mining or construction in the oceans, or if its coastal cities were swallowed by rising seas, the finest debris from these activities, microscopic fragments of processed metals, exotic alloys, or even tiny beads of glass from industrial processes, could have settled into this deep, quiet mud and been buried. Over millions of years, this mud would become rock, preserving these particles like flies in amber. The challenge, of course, is accessing this record. The oceanic crust is young and is eventually subducted, but the sedimentary layers on top of it in stable areas can be very old. Drilling into these deep-sea sediments is one of the great achievements of programs like the Integrated Ocean Drilling Program, but it is expensive and complex. The cores retrieved are meticulously analyzed for clues about past climate and life, but no one is actively looking for microscopic technofossils. To do so would require processing immense volumes of ancient deep-sea rock and scanning them with advanced imaging and chemical analysis techniques, looking for a single, anomalous grain amidst quadrillions of natural particles. It is the ultimate needle-in-a-haystack search, yet the possibility remains. A single, minuscule sphere of a perfected alloy found in a 300-million-year-old abyssal chert would be evidence that would shake the world. It would be more durable than any bone, more telling than any isotope spike. It would be a solitary, perfect artifact from a world lost to time. These searches in the deep rock and the deep sea are the most speculative aspects of our inquiry. They are not likely to be undertaken without a compelling reason, but they complete our meditative journey by encouraging us to think of the entire planet as a potential archive. They ask us to consider that the evidence we seek might not be in the familiar places we associate with history, but in the darkest, quietest, and most enduring corners of the earth, waiting with infinite patience for a curious mind armed with the right tools and the right question to finally uncover it. It is a thought that lends a sense of mystery to every deep drill core and every oceanographic survey, a quiet hope that the next sample might contain not just a record of Earth's past, but a message from it. As we near the contemplative culmination of our journey,
we must gently steer our thoughts toward the most elusive and philosophically nuanced possibility of all, that a form of advanced intelligence could have arisen on Earth millions of years ago, flourished for a time, and vanished without leaving any of the material traces we instinctively associate with civilization. This idea challenges the very core of our search parameters, asking us to consider that our definition of advanced may be tragically narrow, limited by the particular evolutionary path and sensory biases of our own species. We imagine intelligence culminating in technology, in the manipulation of the physical world through tools, machines, and energy systems. But what if another lineage developed a form of advancement that was introspective, ecological, or social? What if their greatest achievements were not in altering their environment, but in understanding it so profoundly that they achieved a seamless, symbiotic existence within it? Their technology might have been neurological or biochemical, not mechanical. Imagine a species that evolved the ability to communicate complex, abstract concepts through subtle shifts of bioluminescence, or one that could store and transmit knowledge across generations through shared genetic memory or intricate culturally sustained oral traditions that made written records unnecessary. Their cities might have been ephemeral, seasonal gatherings for ritual or exchange, leaving no permanent structures. Their most profound artifacts might have been songs, stories, or states of communal consciousness, wondrous and meaningful to them, but leaving no more physical trace than a bird's song leaves on the wind. For such a civilization, the concept of waste, of non-biodegradable byproducts, might be incomprehensible. Everything they used and created would be drawn from and returned to the living world around them. Their legacy would be written not in stone or metal, but in the stability and resilience of the ecosystems they inhabited. After their passing, whether through gradual integration into a new form of being or a quiet decline, the only evidence might be a period of unusual ecological balance in the fossil record, a long stretch of time where extinction rates were low and fossil assemblages show a remarkable consistency, as if the system was being gently managed rather than being subjected to the wild fluctuations of natural selection. We would almost certainly interpret such a period as a fortunate epoch of climatic stability, not as evidence of stewardship. This line of thinking leads us to a humbling conclusion. The most advanced civilization, in a truly sustainable sense, might be the one that leaves the faintest footprint. Its greatness would be measured by its harmony, not its dominance. Its intelligence would be reflected in the health of the world it inhabited, not the scars it left upon it. From this perspective, the silence of the rocks is not evidence of absence, but perhaps evidence of a success so complete that it became invisible. It is the ultimate expression of the leave no trace ethic practiced on a civilizational scale over millions of years. Our frantic, material-based civilization, currently creating a geological layer that will be unmissable for epochs to come, might be seen not as the pinnacle of advancement, but as a loud, clumsy, and adolescent phase. The search for such an ephemeral civilization is, of course, beyond the reach of current science. It exists in the realm of poetry and philosophy, yet it serves a crucial purpose. It expands our imagination about the possibilities of consciousness. It frees us from the assumption that technological progression is the only or even the highest form of advancement. And it allows us to wonder if the greatest achievements of any species might be the quality of its awareness, the depth of its connection to its world, and the beauty of its momentary existence, rather than the durability of its monuments. This is the quietest end to our search. It suggests that if we truly wish to find evidence of other minds in deep time, we should look not for their trash, but for their garden. And if we find a period in Earth's history that seems unusually peaceful, stable, and vibrant, we can perhaps, in a meditative moment, consider that it might not have been an accident of nature, but the signature of an intelligence that learned the most valuable lesson of all: how to live on a planet without conquering it. This thought brings a profound sense of peace. It tells us that the goal is not to be the loudest voice in the geological record, but perhaps the most harmonious. In our tranquil exploration of Earth's deepest past, we must now widen our perspective to encompass not just the planet itself, but its place in a dynamic and sometimes violent cosmic environment. The solar system is not a static, safe vault. It is a region periodically swept by galactic events and celestial interactions that have the power to sterilize surfaces, trigger mass extinctions, and fundamentally reshape planetary conditions. Could an event of such magnitude have occurred within the last 100 million years, one powerful enough to not only cause a biological catastrophe, but also to scour the planet clean of any prior evidence of a technological civilization? This is not to suggest a deliberate cleansing, but to consider the natural mechanisms of planetary amnesia that operate on a galactic scale. One of the most significant threats comes from nearby supernovae. A massive star exploding within 100 light-years of Earth would bathe the planet in intense radiation, gamma rays, X-rays, and cosmic rays, that could last for months or years. This radiation would not only trigger mass extinctions by damaging the ozone layer and causing mutagenic damage to life, but it could also have a profound effect on the surface of the planet itself. The energy input could ignite global wildfires, effectively cremating the landscape and oxidizing any exposed refined metals or surface structures.
The resulting layer of ash and soot would then bury what remained, but the intense heat and radiation might also break down complex synthetic molecules, erasing the more subtle chemical signatures a civilization might have left behind. Another cosmic event is a gamma-ray burst, an even more energetic explosion than a supernova, though rarer and typically originating from much farther away. If one were to be directed at Earth from within our galaxy, its effects would be similarly catastrophic, but even more intense. The flash of radiation could photodisintegrate molecules in the upper atmosphere, creating a cascade of chemical reactions that would produce a smog of nitrogen oxides, obscuring the sun and triggering a global ice age. The combination of initial radiation blast and subsequent long-term winter could be enough to reset the geological clock, wiping the surface clean of all but the most deeply buried and durable evidence. Beyond radiation events, there is also the ever-present threat of impacts. While an asteroid impact large enough to cause a mass extinction is a rare event, it is a proven one. The Chicxulub impactor 66 million years ago not only ended the age of dinosaurs, but also ejected vast quantities of material into the atmosphere and generated global wildfires and tsunamis. An even larger impact, or a cluster of impacts, could have been even more destructive. The energy released could have been sufficient to melt surface rocks, vaporize entire regions of crust, and churn the upper layers of the planet through immense earthquakes and volcanic responses. Such an event would not just bury evidence, it would pulverize it, melt it, and mix it back into the geological cycle with extreme efficiency. The evidence for such events is itself written in the rocks in the form of impact craters, layers of iridium and other extraterrestrial elements, and evidence of sudden environmental change. We know of several major extinction events in Earth's history whose causes are still debated. Could one of them conceal a deeper mystery? If a civilization existed prior to one of these cataclysms, its traces would have been directly in the path of the equivalent of a planetary reset button. The resulting geological layer would tell a story of utter destruction, and any prior subtle signals would be overwritten by the stark signature of the cosmic event itself. This perspective is strangely calming. It suggests that the emptiness we find when we look back may not be a reflection of our loneliness, but a testament to the violence and dynamism of the universe we inhabit.
The silence in the rocks is not necessarily empty. It may be the quiet after a storm of unimaginable ferocity. It reminds us that preservation is the exception, not the rule, on an active planet in an active galaxy. Our own civilization's traces are being laid down during a rare period of cosmic calm. It lends a new urgency to our own efforts to become a multi-planet species, not just for exploration, but for survival, to ensure that our story, if it is to be told at all, is not erased by the next random event from the depths of space. And it leaves us with a final, peaceful thought, that the search for others may be difficult not because they never were, but because the universe itself, in its immense and powerful processes, is very good at keeping secrets. As we approach the final stages of our contemplative journey, we arrive at a point of profound reflection that transcends mere evidence and enters the realm of meaning itself. The investigation into a potential deep-time civilization is, at its heart, an inquiry into the nature of memory itself, not personal or cultural memory, but planetary memory. What does Earth remember? How does it remember? And what does the apparent silence of the rocks tell us about our own place within this vast unfolding story? Earth's memory is not like our own. It is not a record of events, but an accumulation of consequences. It remembers not the actor, but the action. A volcano erupting, a continent colliding, a species going extinct. These are the things inscribed into the geological record. The subtle nuances of intention, culture, and consciousness, if they are not expressed through massive, planet-altering actions, are simply too faint to be preserved against the background noise of natural processes. This leads to a poignant realization. The planet remembers forces, not faces. It remembers the asteroid impact, but not the dinosaurs it killed. It remembers the glaciation, but not the mammals that huddled through it. And if a civilization existed that did not wield geological scale force, Earth would have no memory of it at all. Its passing would be as forgettable as a single day of sunshine in a billion-year-long climate cycle. This geological amnesia is not a flaw. It is a feature of a living, dynamic planet. The constant recycling of the surface is what has allowed life to persist through billions of years of change. The resulting layer of ash and soot would then bury what remained, but the intense heat and radiation might also break down complex synthetic molecules, erasing the more subtle chemical signatures a civilization might have left behind. Another cosmic event is a gamma-ray burst, an even more energetic explosion than a supernova, though rarer and typically originating from much farther away. If one were to be directed at Earth from within our galaxy, its effects would be similarly catastrophic, but even more intense. The flash of radiation could photodisintegrate molecules in the upper atmosphere, creating a cascade of chemical reactions that would produce a smog of nitrogen oxides, obscuring the sun and triggering a global ice age. The combination of initial radiation blast and subsequent long-term winter could be enough to reset the geological clock, wiping the surface clean of all but the most deeply buried and durable evidence. Beyond radiation events, there is also the ever-present threat of impacts. While an asteroid impact large enough to cause a mass extinction is a rare event, it is a proven one. The Chicxulub impactor 66 million years ago not only ended the age of dinosaurs, but also ejected vast quantities of material into the atmosphere and generated global wildfires and tsunamis. An even larger impact, or a cluster of impacts, could have been even more destructive. The energy released could have been sufficient to melt surface rocks, vaporize entire regions of crust, and churn the upper layers of the planet through immense earthquakes and volcanic responses. Such an event would not just bury evidence, it would pulverize it, melt it, and mix it back into the geological cycle with extreme efficiency. The evidence for such events is itself written in the rocks, in the form of impact craters, layers of iridium and other extraterrestrial elements, and evidence of sudden environmental change. We know of several major extinction events in Earth's history whose causes are still debated. Could one of them conceal a deeper mystery? If a civilization existed prior to one of these cataclysms, its traces would have been directly in the path of the equivalent of a planetary reset button. The resulting geological layer would tell a story of utter destruction, and any prior subtle signals would be overwritten by the stark signature of the cosmic event itself. This perspective is strangely calming. It suggests that the emptiness we find when we look back may not be a reflection of our loneliness, but a testament to the violence and dynamism of the universe we inhabit. The silence in the rocks is not necessarily empty. It may be the quiet after a storm of unimaginable ferocity. It reminds us that preservation is the exception, not the rule, on an active planet in an active galaxy. Our own civilization's traces are being laid down during a rare period of cosmic calm. It lends a new urgency to our own efforts to become a multi-planet species, not just for exploration, but for survival, to ensure that our story, if it is to be told at all, is not erased by the next random event from the depths of space. And it leaves us with a final, peaceful thought, that the search for others may be difficult not because they never were, but because the universe itself, in its immense and powerful processes, is very good at keeping secrets. As we approach the final stages of our contemplative journey, we arrive at a point of profound reflection that transcends mere evidence and enters the realm of meaning itself. The investigation into a potential deep time civilization is at its heart an inquiry into the nature of memory itself, not personal or cultural memory, but planetary memory. What does Earth remember? How does it remember? And what does the apparent silence of the rocks tell us about our own place within this vast, unfolding story? Earth's memory is not like our own. It is not a record of events, but an accumulation of consequences. It remembers not the actor, but the action. A volcano erupting, a continent colliding, a species going extinct. These are the things inscribed into the geological record. The subtle nuances of intention, culture, and consciousness, if they are not expressed through massive planet-altering actions, are simply too faint to be preserved against the background noise of natural processes. These achievements would leave no fossil trace. A song, no matter how beautiful, leaves no mark on sedimentary rock. A ritual dance under alien stars leaves no imprint beyond the memory of its participants. A shared moment of awe before a natural wonder resonates only in the hearts of those who experience it. The fossil record preserves bones and shells, not feelings or thoughts. It is a record of form, not of mind. This leads us to a humbling possibility. The most advanced civilization to ever exist on Earth might have left no evidence we would recognize as such because its greatness was not in what it built, but in what it experienced and felt. Its legacy would be written in the quality of its existence, not in the quantity of its artifacts. This civilization would have been a climax of conscious experience, a flowering of subjective awareness that bloomed and faded without a trace, known only to itself and to the planet that witnessed it. Furthermore, consciousness may not be a rare pinnacle of evolution, but a potential that has arisen multiple times in different forms. The complex problem-solving of octopuses, the intricate social structures and grief observed in elephants, the cultural transmission of knowledge in cetacean pods, all suggest that the seeds of consciousness are scattered widely across the tree of life. Perhaps millions of years ago, a different species carried these seeds to a fruition we cannot detect. Their intelligence might have been communal, distributed, and ecological, focused on maintaining balance rather than exerting control. They might have possessed a deep intuitive understanding of their ecosystem, a knowledge passed down through generations, not in books, but in stories, traditions, and ingrained behaviors, a wisdom that left the world untouched rather than transformed. To search for this is to search for a shadow. we might look for periods of exceptional ecological stability in the fossil record, eras where extinction rates were unusually low and biodiversity unusually high for prolonged periods. We might wonder if such balance was a fortunate accident of climate or whether it was nurtured. But we could never prove it. This line of thinking ultimately transforms our quest from an archaeological mission into a philosophical meditation. It asks us to expand our definition of civilization to include possibilities beyond the material. It challenges our human-centric view of progress and invites us to consider that the peak of evolution might not be a species that conquers its planet, but one that fully harmonizes with it. The silence of the deep past, therefore, becomes not an empty void, but a space filled with potential. It allows for the possibility of silent, beautiful histories, whole sagas of conscious experience that rose and fell like waves in an ocean of time, leaving behind no wreckage, only the quiet satisfaction of having existed fully and gently. This is the most peaceful conclusion of all. It suggests that the value of a mind is not in what it leaves behind, but in the quality of its moment in the sun. It encourages us to value our own consciousness, not for its ability to reshape the world, but for its capacity to appreciate it, to feel wonder, to love, to create, and to connect. And it leaves us with a sense of deep kinship with all conscious life, past, present, and future, known and unknown, each playing its part in the beautiful, mysterious unfolding of awareness on this pale blue dot we call home. And so, we reach the gentle end of our journey, not with a definitive answer, but with a deepened sense of wonder and a quiet acceptance of the mystery. We have wandered through the vast corridors of deep time, sifted the subtle sands of geology and chemistry, and expanded our imagination to consider forms of intelligence and civilization that leave no monuments, only echoes in the patterns of life itself. The silence we encounter in the ancient rocks is profound, but it is not empty. It is a silence filled with the breathing of the earth itself, a dynamic, ever-changing planet that remembers in broad strokes of ice ages and extinctions, but forgets the delicate details of individual lives, and perhaps even entire cultures. This planetary amnesia is not a failure of record-keeping, but a necessary process of renewal, allowing the story of life to continue through billions of years of cosmic turmoil. Our search for a prior civilization, though it may never find physical proof, has granted us a priceless gift: perspective. It has allowed us to see our own moment in time with new eyes. We are living at the dawn of a new geological epoch, the first conscious force to inscribe its presence so indelibly upon the planet. The responsibility is immense, but so is the opportunity. The blank slate of the deep past tells us that the story of intelligence on Earth is still being written, and we are its authors. What will our chapter say? Will it be a brief, fiery flash of consumption, or an enduring tale of a species that learned to live in harmony with its home? The possibility of those who may have come before us serves as a quiet mirror. It reflects our own potential futures back to us, not as a warning, but as an invitation. An invitation to choose wisdom over waste, harmony over domination, and legacy over oblivion. It encourages us to think not in terms of years, but in terms of eras, to be good ancestors to a future we will never see. Perhaps the greatest truth we have uncovered is that the value of a civilization may not be measured by the durability of its artifacts, but by the quality of its existence, the depth of its connection to the world, the richness of its consciousness, and the kindness it leaves in its wake. The most advanced civilization might be the one that leaves the lightest footprint, whose greatness is measured by the health and beauty of the world it inhabited. As we close this meditation, let us carry forward not a certainty, but a calming wonder. Let the deep time of our planet be a source of humility and inspiration, a reminder that we are part of a story far greater than ourselves. And let us strive to ensure that the layer we leave behind, whether it is the last or merely the first of its kind, tells a story that future beings, if they ever exist, will look upon with respect and perhaps even a sense of kinship. For now, the page is open, the pen is in our hand, and the quiet, patient earth awaits the next word. Good night, explorer. Sleep well, and we will meet again in our next journey.